All right, ladies and gentlemen, we are on page 2 of our Unit 8 notes. The notes are on Introduction to Functions and Function Notation. Today's lesson is going to set us up for our units for the rest of the school year. So everything that we're going to do for the rest of the school year is going to be based on the fact that they are mostly going to be functions. So this lesson is extremely important. So let's take a look and see what is a function to begin with. So let's read what it says. The concept of the function ranks near the top of the list in terms of important algebraic concepts. Almost all of higher level mathematical modeling is based on the concept. Like most important ideas in math, it is relatively simple. So here we've got the definition of a function. So we're going to read this definition right here. A function is a clearly defined rule. So it's important that it's a rule that converts an input into at most one output. These rules often come in the form of either equations, graphs, tables, or verbal descriptions, or a combination of any of the four things. So the most important thing you need to understand is that each input can only have one output, no more than that. Okay, so let's take a look and see what we have here. Consider the function rule, exercise number 1. Multiply the input by 2, then subtract 1 to get the output. So let's look at question A. It says fill in the table below for inputs and outputs. Inputs are often designated by X and outputs by Y. So normally what we have is our input is going to be our X value, and then our output is going to be our Y value. So the rule says to multiply the input by 2, so I'm going to multiply our input by 2 and then subtract 1, and that's how you get the output. So I'm literally going to multiply the input, which is 0, by 2, and then I'm going to subtract 1. So then I end up getting 0 minus 1, which gives me negative 1. So my output is negative 1. So now let's do it for the next input, and you can have infinite inputs, okay? So right here, I would multiply my input by 2, just like it always says to do, and then subtract 1. So you end up getting 2 minus 1, which is 1. I want you to pause and try figuring out the outputs for 2 and 3 as our inputs, and then come back and see how you did. All right, so you should get that the outputs for the remaining 2 inputs were 3 and 5, and if you notice, it should increase by 2. Our output should increase by 2, and that makes sense because you're multiplying by 2. So now it says write an equation that gives this rule in symbolic form. So the rule says multiply the input by 2. The input will always be X. So I'm going to take X and multiply it by 2, and then I'm going to subtract 1, and that gives you the output, so equals Y. So in this specific example, we actually have a linear function because it's in the format y equals mx plus b, and it makes sense that each one of these values is going up by 2 because the slope is 2. Okay, so now part C says to graph the function rule on the graph shown below. Use your table in A to help. Or you can just use the fact that you know linear functions to begin with. So I'm going to say this is 0. You can number it however you want. I'm just going to go by 2's. And then all you have to do is just graph out your values. Now, if you notice, I have used the word function quite often in class, and I'm not sure if you guys have noticed that. But now that you understand what a function is, I expect that you guys use that vocabulary as well. So our first coordinate has an input of 0 and an output of negative 1. So I'm going to go to 0 on the x-axis and negative 1 on the y-axis, and I'm going to draw a dot there. The next one, I'm going to start at 1 on the x-axis and 1 on the y-axis and put a dot there. Keep going. The next coordinate is 2, 3, and then the last coordinate that we have is 3, 5, but it doesn't mean that it ends here. It just means that I'm done making my chart. So I'm going to connect my dots and draw an arrow to indicate that this function can go on forever. Okay? So you guys already have been exposed to functions. It's just the notation is going to be a little bit different, and now you understand what a function actually is. So exercise number 2. In the function rule from number 1, what input would be needed to produce an output of 17? Why is it harder to find an input when you have an output than finding an output when you have an input? So let's figure out what the output would be. So see if you can figure out what it would be. You want an output of 17, so figure out what the input should be. Go ahead and press pause and then come back to me when you figured it out. So hopefully you got 9, but let's talk about why the answer is 9 algebraically. This time we have our output. We know the y value. So if our equation that we figured out in part B right here is y equals 2x minus 1, all I have to do is plug 17 in for y. So 17 equals 2x minus 1, and then you just have to solve this equation. So add 1 to both sides, you get 18 equals 2x. Divide everything by 2, you get 9 equals x. So your input would be 9. So why is it harder to find an input when you have an output than finding an output when you have an input? I want you to think about that, and we're going to discuss this question next time I see you guys in class. Okay? So now let's move on to exercise number 3. A function rule takes an input n and converts it into an output y by increasing 1/2 of the input by 10. Determine the output for this rule when the input is 50 and then write an equation for this rule. So it says that you're taking your input and you are taking 1/2 of the input, and then you are going to increase it by 10. So if our input is 50, all you have to do is just take half of 50, which is 25, and then it says that you have to increase it by 10. So 25 plus 10 gives you 35. So this right here would be your output, okay? So then it says to write an equation for the rule. So your output is equal to 1/2 of your input increased by 10, okay? All right, let's take a look at page 3. At the top, we'll read through what it says. Since functions are rules that convert inputs, typically x values, into outputs, which are typically y values, it makes sense that they must have their own notation to indicate what the rule is, what the input is, and what the output is. So in the first exercise, I'm going to explain how to interpret this notation. So exercise number 4. For each of the following functions, find the outputs for the given inputs. So in question A, it says f of x equals 3x plus 7. I want you guys to write down that this means f of x. And hopefully you were able to conclude that f would stand for function. So we have some function of x, which is equal to 3x plus 7. Now you just need to understand this is the same thing as y equals 3x plus 7, where x is your input and y is your output. But this time we're going to say that x is our input and f of x is our output, okay? Now, a lot of people think this is f times x. This does not mean multiplication. All this means is that I'm going to figure out my output, or my f, when x is my input. That's what this means. So here, it says f of 2. So that means that 2 is my x, or my input, which should make sense to you because this says f of x. So if this right here is an x, then that means that x is 2. So all I need to do is plug 2 in every time I see an x. So 3 times 2, and then just copy the rest of the problem down exactly how you see it. So you get 3 times 2, which is 6. 6 plus 7 equals 13. Okay, now, guess what? You guys have been doing function notation since the beginning of the school year because I've told you to take the 2, store it in as x, and then type in 3x plus 7 into your calculators, and your calculators only uses functions. So it realizes that x is your input and you're trying to figure out what your output is, okay? Now, sometimes it doesn't have to be f of x. It could be any letter you want it to be. So here's a new function. It's called g of x, so you don't get it mixed up with f of x. It's a new function. So same thing, I'm going to do the exact same thing. Here, my x value is 20. So every time I see an x, I'm going to replace it with a 20. So this would be 20 minus 6 over 2. So then you end up getting 14 over 2, which is 7. So again, what this means is when your input is 20, your output is going to be 7, okay? It's kind of like a machine. You're just plugging it in, and then you're chugging out an answer, okay? All right, and then our last example here is h of x, which is the square root of 2x plus 1. So in this example, our x value is 4. So every time I see an x, I'm going to replace it with a 4. So it's going to be 2 times 4, all right, plus 1, but it's all being square rooted. So then I end up getting the square root of 8 plus 1, which means that I will get the square root of 9. So my answer here is going to be 3. So when my input is 4, my output is 3. So what I want you to do right now is please figure out the remaining missing values before you continue watching the video, and then come back and check to see how you did. All right, so your answers respectively should be -2, -3, and +1. If you don't understand how I got these answers, your work is in front of you, so please press pause before you move on so you can make sure you really understand how to do this, all right? Okay, so then let's read what it says underneath. Function notation can be very, very confusing because it really looks like multiplication due to the parentheses, but there's no multiplication involved, which we said before. So the notation serves two purposes. 1, to tell us what the rule is, and 2, to specify an output for a given input. So basically, right here, your y, your output, is equal to your f of x. F is the rule. So here, our rule in this first example right here is that you have to take your input, multiply it by 3, and increase it by 7. Here you have to take your input, subtract 6, and divide it by 2. And that's how you get your respective outputs. So again, it gives you two rules. It gives you how to find your output based on your given input, and then it also tells you what your actual inputs and outputs are. So question number 5, exercise 5. Given the function f of x equals x over 3 plus 7, do the following. So question A says to explain what the function rule does to convert the input into an output. So basically, all you have to do is take your input, divide it by 3, and then add 7. So that's what we're going to write down. Take the input, divide by 3, or you could say take 1/3 of the input, whatever you prefer, and then increase by 7. To get the output. Okay, so question B says to evaluate f of 6. So I'm going to take my given input. So this again, it tells me that my input is 6, and I'm going to plug it in every time I see an x for my input. So I'm going to plug 6 in for my x right here. So then I end up getting 6 divided by 3 is 2, 2 plus 7 is 9. So when my input is 6, my output is 9. Let's do the next one, f of -9. So here my input is -9. What's my output going to be? Well, in order to figure that out, I have to divide my input by 3, and then add 7 to it. So I'm going to take -9 divided by 3. I end up getting -3. Add 7 to it, you get 4. So when your input is -9, your output is going to be 4. Okay, hopefully that makes sense to you. All right, fantastic. So question C, find the input for which f of x equals 13. Show the work that leads to your answer. So this time, I don't know my input. My input is unknown, but I do know what my output is. I know my output is going to be 13. So if f of x equals x over 3 plus 7, instead of plugging 13 in for x, I'm going to plug it in for f of x. So 13 is equal to x over 3 plus 7. Then all I have to do is just solve for x, so subtract 7 from both sides. You end up getting 6 equals x over 3. Multiply everything by 3, you end up getting 18 equals x. Okay, so this is the input that you need to get an output of 13. Okay, now question D is really tricky. It says, if g of x is equal to 2 times f of x minus 1, then what is g of 6? So again, we know our input this time, and I want to figure out what my output is going to be, but this time we have double outputs. So let's plug in our information. We know that we want to figure out what g of 6 is. So every time I see an x, I'm going to replace it with a 6. So g of 6 is equal to 2 times f of 6 minus 1. So now all I have to do is figure out, well, what is f of 6? So let's figure out what f of 6 is. So we know f of 6 is equal to 6 over 3 plus 7. So this is our first step, which is 2 plus 7, which gives me 9. So now I know this information. I know what f of 6 equals. If f of 6 equals 9, then to figure out what g of 6 is, all I have to do is just plug this 9 in for this f of 6. So 2 times 9 minus 1. So I end up getting 18 minus 1, which is 17. Okay? All right, so let's take a look at page 4 of our notes. It says to recall that function rules commonly come in one of 3 forms. 1, equations, as in the previous exercise, 2, graphs, and 3, tables. The next few exercises will illustrate function notation with these 3 forms. So we already did function notation with our equations. Now we're going to figure out how we can use our charts or our tables to help us out. So exercise number 6. Boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours H. So if T is a function of the number of hours H, then H right here is your input and T right here is your output. Okay, so it says to evaluate T of 2 and T of 6. So what is the output? This is asking you, what's the output of temperature when T, your input, is 2? So after 2 hours, what is the temperature going to be? So T of 2 is going to equal 104 degrees. Okay, so now please figure out what T of 6 is going to be. Hopefully you wrote down that T of 6 is 68 degrees. Okay. Now, question B, for what value of H is T of H equal to 76? So this time you know your output and you need to figure out what the input is. Well, when the temperature is 76 degrees, how long does it take to get to that? It takes 4 hours. So that means that H equals 4 hours. Okay? So now, question C says, between what 2 consecutive hours will T of H equal 100? Explain how you arrived at your answer. So I want you to figure this out, write your explanation, and then come back to me and press play again when you feel like you have the right answer, or you feel like you're ready to move on. Okay, so you should get between 2 and 3 hours. And the reason why is because T of 2 is equal to 104, and T of 3 is equal to 85, and the temperature is decreasing. Therefore, 100 degrees will be reached between 2 and 3 hours. Okay? So that's how you deal with charts. So now let's look at graphs. The function y equals f of x is defined by the graph shown below. It is known as a piecewise linear function, which we've done a little bit of at the beginning of the school year, but we'll go more in depth with that this unit, because it is made up of straight line segments. So remember, if you remember at the beginning of the school year, this has 1, 2, 3, and 4 different pieces because there's 4 different straight line segments that combine to make this function. Answer the following questions based on this graph. So just so that you know, the scale is each line right here represents 1. Okay, so evaluate each of the following. The first thing it asks you to find out what f of 1 is. So when my x equals 1, when my input equals 1, what is my output? So if I go to 1 right here on my x-axis, it lines up with 4 on my y-axis. So that means that when my input is 1, my output will be 0. It will be 4. Okay? All right, so now let's find f of -3. Well, f of negative 3 happens right here at negative 3 on the x-axis. So then I go down to where the graph is, and it's at negative 4. So that's my y value. My corresponding output is negative 4. Okay? So please press pause and try question or the next two examples, f of 5 and f of 0, and then come back to see how you did. All right, so f of 5 will occur when x equals 5. So I go to 5, and then I go down. That means my y value or my output is negative 2. And then when f of 0, right here, it means x is 0, so my output is 2. Okay? All right, question B. Solve each of the following for all values of the input x that make them true. So here I have my output this time. It tells me that f of x, or my output, is 0, and I don't know what my input is. When does this occur? So this time I'm going to look for my y values being 0. So where is y equal to 0? So like right here, y is equal to 2. Right here, y is equal to 4. Over here, y is equal to negative 2. So y equals 0 when x is negative 1. Okay, when x is positive 4, because y equals 0 right at positive 4, and when x is equal to 7. Hopefully that makes sense to you. And if you need some help, think about it like this. It just means you're trying to find out when y equals 0. Well, y equals 0 at each one of the following situations. Okay, so then figure out when f of x equals 2. You should get 2 different answers. So go ahead and try that and then come back to me to see how you did. All right, so you should get that f of x equals 2 when x equals 0, because right here the y value is 2, and when x equals 3, because right here the y value is also 2. Okay, and again, you can do the same thing. Just draw out a straight line, because this just means that y equals 2, which is a horizontal line. So that's the 2 places where y equals 2. Okay, all right, so now let's take a look at question C. What is the largest output achieved by the function, and at what value of x does it hit? So I want you to see if you can figure that out on your own, and then come back to me to see how you did. Okay, so you should get that the largest output is equal to 4, because right here, this is your highest value right here. So it happens at our highest value, but at what x value does it hit? When x equals 1. So we can basically just say that our largest output could happen when f of 1 equals 4. Okay? Make sure to write any questions that you have on the side or on the margin, so that way I can answer any questions that you have next time I see you in class. Have a great day.